All right, so in the last videos, we talked about all the single bonds that you have on a central atom in the different groups. What if I start throwing in double and triple bonds? Things are going to change a little bit. Remember that a double bond is one domain. A triple bond is one domain. Not only do you lose a domain when you have a double or a triple bond, you also lose one of the p orbitals in hybridization. So carbon is normally sp3 hybridization, but when carbon forms a single bond, it goes down to sp2 hybridization. When carbon forms a triple bond, it goes down to sp hybridization because it loses a domain, which means it loses hybridization. So that's really important to help you predict the shape of molecules. Okay, so I've got a couple up here that I want to do. CH2O. So if we do the Lewis structure, hopefully you realize that there's a double bond. Oops, put in my Lewis dot structure. There's a double bond between the carbon and the oxygen. Now, these non-bonding orbitals on oxygen aren't going to matter because it's the central atom shape that we're concerned about. So let's look at what we have. We have 1, 2, 3 domains. Not 4 domains, 3 domains. So if you look back on your organizer table, 3 domains is sp2 hybridization. We're not going to get into details about why one of those double bonds isn't involved in hybridization. That's an AP question. But just know that if I go down to 3 domains with that double bond, it's sp2 hybridization. And so 3 things around a central atom, what's that angle going to be? 120 degrees. So carbon is going to have a 120 degree angle around it. One of those bonds is going to be the double bond to oxygen. One is to hydrogen, the other is to hydrogen. So what's this shape? It is not tetrahedral. There are not 4 domains. There are only 3 domains. So this winds up being trigonal, planar. Okay, I lost a domain, I lost a hybrid orbital, I changed the shape. If I go to HCN, okay, draw the Lewis structure, I've got a triple bond to nitrogen, single bond to hydrogen. Yep, nitrogen's 2 electrons are still there, but they're irrelevant because carbon's our central atom. That's what we care about. So 1, 2 domains. Both of them are bonding. 2 domains is sp hybridization. Sorry, that's a Z. Got a little ahead of myself on the spelling. Okay, so 2 domains, sp hybridization. How far apart are those 2 things going to spread? 180 degrees. So it's really important to remember that when you have a double bond or a triple bond, hybridization decreases, the number of domains decreases. And so the shape is going to be different. Carbon is not always tetrahedral. Carbon single bonded is tetrahedral. You start throwing double and triple bonds in there and it changes. Okay, so I have 2 other molecules here that I want you to give a shot to. Okay, I know there's 2 carbons here, so pretend that just 1 carbon is the central atom. Okay, figure out what the shape around that 1 carbon is. And then PSH, this one's tricky. If you can do this one, you understand the idea of hybrid orbitals and VSEPR theory. Okay, so pause the video and give it a shot. So you're back. Hopefully you've given it a shot. And let's take a look at what you've got. So carbon has to form a double bond. Sorry, I didn't do the Lewis structure really. I did the 3D shape. Okay, carbon has a double bond. So there's 1, 2, 3 domains around each carbon. So what's this shape going to be? Trigonal planar. This is 120 degrees at all angles. All of those are 120 degrees. So that's going to be a trigonal planar shape. O-N-A-L. Okay, hopefully that one was pretty straightforward as soon as you realized you needed a double bond with the carbons. All right, PSH. What's my central atom going to be? Phosphorus is the thing that needs the most bonds, so phosphorus is going to be my central atom. There's a Lewis structure for phosphorus. 1 hydrogen. So then sulfur is going to form a double bond, right? So count domains. 1, 2, 3. So I have 3 domains. So what's the electron geometry? 3 domains, 120 degrees, right? But what's different here? Not all of these domains are bonding. This is a non-bonding domain. So I have 2 bonding, 1 non-bonding. So do I really have 3 sticks sticking out of my marshmallow? No. I only have 2 sticks sticking out of my marshmallow. So what's this shape going to be? Bent. So if you got that one, you understand all the little intricacies about VSEPR theory. If you didn't get that one, you got lots of chance to practice.